welcome to another GCSE revision video, and in this video we're going to be looking at the difference of two squares. If you have a set of brackets where you have x minus a number into x plus a number, and remember that could be either way around, you could have x plus a number into x minus a number. When we expand out the brackets we get x squared plus ax minus a squared. The two ax terms will then cancel out, leaving us with just x squared minus a squared. This is called the difference of two squares. So any quadratic equation in the form ax squared minus c can easily be factorised into the square root of ax plus the square root of c into the square root of ax minus the square root of c. And that's all there is to it for the theory part. There really is nothing to it with the difference of two squares. It really is just that easy. Let's have a go at doing a few examples just to show how easy it is. Let's pick something like 4x squared minus 16. Okay, so to take the difference of two squares here, all we're doing is taking the square root of 4, which is 2. Square root of x squared is just x, and then minus the square root of 16 is 4, and then that goes into 2x plus 4, and that is all there is to it. It is just that easy. Let's try another one. Okay, let's try something that's not quite so obviously a difference of two squares. Let's try something like 3x squared minus 12. Okay, 3 is not a square number, 12 is not a square number. That doesn't stop you using the difference of two squares. There's no reason you can't have radicals inside your brackets. However, if we pull out the 3, we get 3 into x squared minus 4. And of course x squared is a square number and 4 is a square number. So now we can factorise that using the difference of two squares. So that's x minus 2 into x plus 2. So sometimes the difference of two squares might not necessarily look obviously the difference of two squares, but even if these numbers are not square numbers, there is nothing wrong with you putting radicals inside the brackets. Okay, well we just saw an example of something that looked like it wasn't the difference of two squares but actually was the difference of two squares. Now we're going to look at something that looks at first glance like it might be the difference of two squares but actually is not the difference of two squares. Even though we've got a square number here and a square number here, this is a sum, it's plus, it's not a difference of two squares. In order to be the difference of two squares, this operator needs to be a minus sign. Okay, well we could try to be clever and pretend that it's a minus sign, and we could say something like, yeah, but if we say this is x squared minus negative 4, then suddenly we've got the difference of two squares. Well, have we? Is negative 4 really a square number? Is there any real numbers that when multiplied by each other are going to come up with negative 4? Remember, you have to multiply a number by itself. So if you take any positive number and you multiply it by another positive number, you're going to come up with a positive number. And negative 4 is not a positive number. So if you take a negative number and you multiply that by a negative number, well, a negative times a negative is also a positive. So negative 4 has no real square roots. So we cannot factorise this at all. It has no real factors. In truth, there are a set of numbers that we call imaginary numbers that we can get around this issue, but this is much more abstract than the sort of maths we deal with at GCSE level. And if you want to know more about imaginary numbers, I'm afraid you will have to study maths to A level standard. Okay, why don't you have a go at practicing some examples of the difference of two squares? I'd like to wish you all the best with your revision and all the best with your exams, and I'll see you in another video.